In this movie, you'll find out more about how to determine the energy demand of the heating, cooling, and ventilation systems of the building. For the architects and for their clients, the most important energy-related question is to determine the overall energy demand of the building. Eco-Designer Star is able to provide quick and very accurate building energy demand calculations. Let's display the Supply Building System panel on the Energy Model Review palette. Here you can see all the building systems listed: heating, cooling, and ventilation. Let's now open the Building System Settings dialog to have a closer look at the details of each system type. There are two options available for heating: the thermostat controlled and the free float type. Please note that the very same options are available for cooling as well. The thermostat controlled option activates the internal temperature constraint in the assigned operation profile. Let's select this for the heating type and see how it works. Let's open the Operation Profiles dialog and display the Daily Profile Editor. Please note that the working hours on workdays have a minimum and a maximum threshold for the internal temperature. At the same time, the non-working period does not have such constraints for the internal temperature. Eco-Designer Star considers this information together with the shape of the building, insulation, and external temperature to determine the energy demand of the building. If the temperature rises above the maximum or falls below the minimum values provided at the operation profile, then the energy demand of a cooling or heating system will be automatically added to adjust the overall energy demand. If no minimum or maximum internal temperature value is set for an operation profile, then the internal temperature will be influenced only by the building envelope characteristics and by the external weather conditions. In this case, no energy demand adjustments will be carried out in the corresponding thermal blocks. The free float heating or cooling type refers to an area without any mechanical heating or cooling systems. If the free float heating or cooling system type is assigned to an operation profile, then no energy demand adjustments will be carried out in the corresponding thermal blocks. There are three ventilation types available. These are natural, exhaust only, and supply and exhaust ventilation types. Natural ventilation type can be applied if there are no plans to install any mechanical ventilation systems, because ventilation will be provided manually. The exhaust-only ventilation means that a mechanical system will be provided only for the removal of exhaust air. The supply and exhaust ventilation means that a mechanical system will be provided for both the supply and the removal of air. The fan pressure and efficiency values can also be provided in the case of mechanical ventilation systems. These values can be determined with the help of a mechanical engineer. Approximate values can be set using the following draft estimation. Enter 10 Pascal for the fan pressure value for all thermal blocks having only exhaust ventilation type, kitchens, sanitary units, and so on. Enter the value 3000 Pascal for staircases. Enter the value 1500 Pascal for all the common supplies, such as offices. The fan efficiency value is determined by the efficiency of the selected air-to-air heat exchanger, or so-called recuperator. 85% efficiency is the average value here. Let's open the operation schedule. Here we can reduce the energy loss due to ventilation by scheduling the ventilation intensity on a daily and weekly basis. The ventilation intensity can be reduced for the non-working time periods. We can change the unit of the airflow unit with the help of the pop-up list. Let's see a couple of examples on how to adjust various properties of the building systems. Let's select the Management Thermal block from the list of the Energy Model Review palette. And let's display the Building Systems palette. The Management Thermal block should be a thermostat-controlled area equipped with mechanical ventilation. Let's select the thermostat-controlled option for both heating and cooling systems. Let's select the supply and exhaust option for the ventilation. We will enter 1500 Pascal for the fan pressure and set 85% for the fan efficiency value. Let's apply all these adjustments by clicking the OK button on this dialog. Let's proceed and select the staircase thermal block from the list. Let's display the Building Systems dialog again. We will select the free float option for both heating and cooling systems because we do not have to keep a temperature constraint here. Let's select the supply and exhaust ventilation option and enter the value 3000 Pascal for the fan pressure and define 85% for the fan efficiency. Let's select the entrance thermal block from the list and open the Building Systems dialog. Let's define the free float option for both heating and cooling systems and select the natural ventilation type having 1 per hour air exchange rate. Finally, let's see a unique example. The circulation thermal block is located in the middle of the building. This has staircases and corridors. It also has a curtain wall facade at the entrance of the building, and it also has a glazed top above the entrance. Typically, this circulation area should have a thermostat-controlled heating and cooling system. In this example, we will utilize this atrium area as a buffer zone. We will define a controlled natural ventilation for this. Nighttime ventilation is typical for those climates where the air is cool at night and can be used to cool down the building. During the wintertime, solar gain can be provided with the help of the very same glazed atrium. To achieve the above, we will select free float for both the heating and cooling systems. We will define a supply and exhaust ventilation system. However, we will set the fan pressure and efficiency to 0. At the Operating Schedule dialog, we can precisely define the time schedule of the air change intensity by seasons.